This is your video for 8.3, still on trig. We're going to use some of the things we learned last video and add a little bit to it. So San Francisco, California is famous for its steep streets. The steepness of a road is often expressed as percent grade. Filbert Street is the steepest street in San Francisco and it has a 31.5% grade. So what that all means is that you can think of it, if you take 31.5 from a percentage and you turn it over into a fraction, you know that means 31.5 over 100. So that actually represents the slope of the line. Rises at 31.5 feet and it runs 100 feet. So you can put that on your triangle. It rises up 31.5 feet. It runs over 100 feet, which we're going to learn today is equivalent to an angle of 17.5. Which is pretty steep. So we're going to learn how to come up, given 31.5 and 100, we're going to learn how to come up with that angle. Okay. Alright, so use a trigonometric ratio to determine which angle is angle A. So we need to figure out which one or two, which one's the one we want. So we have cosine of A equals 24 over 25. So remember from last class, cosine is adjacent over hypotenuse. So let's pretend it was angle 1. Who's adjacent to angle 1 is 1.4. Who's the hypotenuse is 5. So then we can work that out. 1.4 divided by 5 is 0.28. We know that's not going to be it, but let's just make sure. 24 divided by 25 is 0.96. So these don't match, so it can't be angle 1. Let's make sure it's angle 2. Angle 2, who's adjacent to angle 2, is 4.8. The hypotenuse is still 5. 4.8 divided by 5 is 0.96. So since the numbers that are given match the ratio we were given, then we know that angle A is angle 2. Okay, remember you can't use the right angle until the end of the chapter. So our only choices were 1 and 2. 1 didn't work out, 2 did, so there we go. Okay, this right here is what's going to be the new stuff for today. So last lesson we talked about if I give you angle 30, then the sign of 30, always next to the trig ratio, goes the degree, and that equals the ratio, opposite over hypotenuse. So this would be 1 over 2 for 1/2. Now we're going to learn how to go backwards. So what if I give you the sides and I need you to tell me the angle? So since we're going backwards, we're going to use what's called the inverse. So what you want to make sure, and what you want to write down, this is always the most confusing part, okay? If you get the sides and need the angle, you have to do inverse. If you have the angle, you do regular, like we did last time. Okay, so basically, if you need the angle, if your answer is 50 degrees, 70 degrees, you better have gotten there by doing the inverse. Okay, and just like we did all our trig yesterday on the calculator, you're going to do this the same way. So that's fuzzy, I know. But this is sine, and if you hit second sine, it brings up sine inverse. Okay, so you would type in like sine inverse of 0.5. and out would come the degree, 30 degrees. So the sine of 30 degrees is 1/2. That's what we learned last class. You take regular trig function, you put in the angle, and what comes out is the side ratio. Now we're going to go backwards. I'm going to use sine inverse, and I'm going to put in the side ratio, and my answer is going to be the angle. So which one you use is all going to depend on what you're trying to figure out. If I want the angle, I have to use the inverse. If I want to find a side, I use the regular stuff. Okay, so let's practice. Okay. So let's first start, just like we did yesterday, with practicing typing that in our calculator. So cosine inverse of 0.87, second cosine brings up the inverse, 0.87. And this is round to the nearest degree, so this is 29.5, so that rounds to 30 degrees. Sine inverse of 0.85 is 58.2, so rounded to the nearest degree is just 58 degrees. So all you have to remember is to type the second key. Using given measures to find unknown angle measures or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know either 2 side lengths or 1 side length and 1 acute angle. So that's what we're going to do today, is solve the triangle, and basically it means they're going to give us 2 pieces and we're going to tell them everything else. Okay, so let's practice. Maybe. There we go. Okay, so all day today, the directions are find the unknown measures, round lengths to the hundredth, and angle measures to the nearest degree. So this is one of our new ones for today because they gave me 2 side lengths. So my answer is going to be an angle measure, meaning I'm going to have to do the inverse. Now, there are a lot of choices for these because I have to find 3 things. I have to find ST, I have to find angle T, and I have to find angle R. So you could go in any different order, which means you could have different math going on and still get the right answer. So you pick. I'm going to say we're going to start with angle T. So according to angle T, the 5 is opposite and the 5.7 is the hypotenuse. Now I'm still going to write the equation the exact same way I wrote it yesterday. So I know I'm going to use sine because I have opposite and hypotenuse. So sine of angle T is equal to 5 over 5.7. Now, because my answer is an angle measure, I have to go backwards. I want the variable here and I want the ratio here. I want to switch these 2 things. When you switch something in math, that's called the inverse. So I'm going to rewrite that. Sine inverse, because I'm switching places, 5 over 5.7. And what will come out will be angle 2. Because my answer is an angle, I have to use inverse when I do it. So now I just type that in. Sine inverse of 5 divided by 5.7 is 61.3, but my answer is an angle measure. So angle T is just 61 degrees. Okay? Because I want an angle measure, I'm going to say it one more time. An angle measure is my answer, so I have to use the inverse to get there. Okay? I could do the same thing with angle R, only I don't have to because we can just use what we did yesterday. 180 degrees in a triangle, I already used 90. I already used 61. So angle R has to be 29 degrees. Okay? Now I need to find ST, and there are a couple ways you can do that. You can either do Pythagorean theorem, or you can use a trig function to find ST. And either one's fine. Because we're in the trig chapter, I just want to review for you how to do trig. So I'm still going to be looking according to angle T, just because that's where I started. So 5 is still opposite. ST would be adjacent. So this time I'm going to say the tangent. Now I know T, so I'm going to say tangent is 61 equals opposite over adjacent. And this is just like we did yesterday. The variable's on the bottom, so I switch. ST is equal to 5 divided by tangent of 61. My answer is a side length, so I should not be using inverse. I should just be using the regular stuff. Tangent of 61. Out comes a side length. Side lengths get rounded to the hundredth, so ST is equal to 2.77. And that's a pretty realistic answer. It's the shortest side, the next side is 5, and the longest side is 5.7. Okay, so inverse to find angle measures, regular, just like yesterday, to find side lengths. Okay, try check it out by yourself. But here's a hint that there aren't any inverses in it. This is the same kind of problem as yesterday. Okay, so they gave me the 58, so that's the one I definitely want to start with. So I label my triangle opposite. I'm going to start with X first, so I called that the adjacent. I just named it X. You can name it whatever you want. Because it's opposite and adjacent, I use tangent. Tangent of 58 equals 14 over X. This time the variable is on, or still the variable's on the bottom, so switch and divide. 14 divided by tangent of 58 is 8.75. Then I just switch sides and I go to the other one. So 58 opposite, and that would be the hypotenuse. I called it y so I wouldn't get confused. So now I'm using sine for opposite and hypotenuse, but everything else is the same. 14 over y, switch and divide, and the hypotenuse would be 18.84. Now I can do angle measures easily again, so I just did triangle sum theorem. If this is 58, this has to be 32. Okay, let's do this when it's on a coordinate plane, which is the same process, only we have to set it up ourselves. So we have to count the side lengths, which is not hard. Let me see. This is P, this is Q, and this is R down here. So let's just count. 1, 2, 3, 4, 5. PQ is 5. 1, 2, 3, 4, 5, 6, 7. And PR is 7. These are horizontal and vertical, so I know this is a right triangle. You could do Pythagorean theorem to find the hypotenuse if you wanted to. I'm going to use trig just because that's what we're studying. So again, you're just going to pick an angle, whichever one you prefer. I'm going to choose angle R. So I'm going to label according to angle R. So PQ would be opposite. PR would be adjacent. So then we solve. Tangent of angle R is opposite over adjacent. Because I have to switch places, this and the R have to switch places. When I switch, I'm going to do inverse. So the tan inverse of 5/7 is equal to angle R. If my answer is an angle measure, I have to do inverse. So then I just type inverse tangent of 5 divided by 7 is 35.5. We're rounding to the nearest angle measure, equal degree. So I would just call that 36. You can do triangle sum. If I've already used 90 and 36, then I have 54 left. Now you can use a regular trig function to find PQ. So I'm going to call this X. Still going to use the 36 just because that's how they're labeled. And you choose. Would you rather use 5 or 7? It doesn't matter. It just changes which one you do. I'm going to use 5. So I'm going to have opposite, and I'm trying to find the hypotenuse. So that would be sine. If you had chosen the 7, you would be using cosine, but we would get to the same answer. So sine of 36 is equal to opposite over hypotenuse. The variable's on the bottom. So I'm going to switch and divide. So I'm just going to type 5 divided by the sine of 36. That must mean the hypotenuse is 8.51 units. And that is a reasonable answer. 5/7, the hypotenuse should be the biggest. So 8.51 seems to be a good one. Okay, our last example is the percent grade that we referred to at the beginning of with the San Francisco Street. Now we're going to do one by ourselves. So a highway sign warns that a section of road ahead has a 7% grade. Now we just learned 7%, anytime you have percent, you just change it by putting it over 100. And now this is like your slope. This is your rise, and this is your run. So we're going to create a picture based on this information. I'm going to rise up 7 and run over 100. Then the question says, what angle does the road make with the horizontal line? So it's asking, who's this bad boy over here? So then you label. According to this angle, 7 is opposite, and 100 is adjacent. So that leads me to do trig. Now here's the key. Anytime you have this set up, how about that leads me to do tangent? Anytime you have this, tangent is going to be your way to go. So tangent of this degree, I'm going to call him X just for simplicity, equals opposite over adjacent. My answer is going to be an angle measure. So I have to switch places, which means I have to do inverse tangent. If your answer is an angle measure, you better be doing inverse. Press enter. 4 degrees, which that really puts into perspective how much how steep that San Francisco Street is. If this warrants enough for a road sign to say, hey, watch out, this is a 7% grade, and it's only a 4-degree angle, how steep is Filbert Street that is a 17.5-degree angle and a 31.5% grade? That's pretty steep. Okay, see you tomorrow.